My name is Aditya and I work for BrowserStack.com as lead of systems engineering. I contribute to Fedora project towards their infra and cloud teams. Right, so today we are going to go and look at the fault tolerant nature of Kubernetes. Right. Okay. How many of you are actually aware of Kubernetes? What exactly is Kubernetes? By show of hands. Okay. How many of you are aware of Docker containers? Right, bunch of you. Okay. So with Kubernetes, what we are trying to achieve is a way to orchestrate how your containers boot up, boot down, how they talk to each other, how you can manage them very well, how you can create a highly available cluster. And today I'm going to specifically talk about the fault tolerant nature other than anything else. So yeah, so what problem that we are trying to solve? We are trying to solve the problem that I want my services to run. I don't care what it takes, right? If I want an instance of my application along with a front end web server along with a back end, I want them up. I don't care how you do it, but I just want them up. So that's the problem that we are trying to solve. Now, before we deep dive, I'm going to walk you through a couple of demos. And since the demos are working on all my machines and everything, it might be a little slow. So I encourage you that you ask the questions as and when you have, and don't wait till end. Am I audible till end? Yep. Okay. Awesome. Right. So, all right. So, Kubernetes world is divided into certain components. Okay. The smallest entity in Kubernetes world is what we call as a pod. Okay. Now imagine a pod of peas with each individual pea is a container. So you can have a bunch of containers in a pod, and that pod is an indivisible entity. So when you say that I want to run a Kubernetes pod, you mean that you want to run a stack. That stack can consist of one container. That stack could consist of 10 containers or how many you want. Right? So pod is nothing but a logical collection of containers. We are good with this definition? Awesome. So yeah, as I've already said, it may consist of multiple containers. You can mount external disks to the pod as a single entity. So once you mount the disk or volume is available throughout all the containers. You don't need to individual mount. Network is really transparent in the sense that one pod can talk to another pod on localhost. You don't need to manage networking. Now, networking, if you guys have worked with Docker or any orchestration tool around Docker, you must be knowing that networking is a really big pain point in Docker world right now, right? Because making two containers talk or making two containers on separate hosts talk is really a nightmare. So Kubernetes tries to simplify it. We are not there yet, but we are still, it simplifies it to a large extent. Right, so what exactly is a pod and how fault tolerant it is? Let's try to check that out. So, where is my screen? Which one of them is ready? What this means is that one of the virtual machine is ready to handle containers or whatever pods I asked it to run. Okay. So I'm just going to show you how a container is built, like a very quick walkthrough. So yeah, so Kubernetes definition is basically declarative. You tell it what target you want, and then Kubernetes works to achieve that. So in this case, what we have right now is that I want one pod which will run a Nginx Flask demo. It will download the container images which are written there, and it will run the specified command. I have defined a container port and a host port. So container ports are the one which will be exposed. So I'm sure you guys must have worked with Docker expose command, right? Docker publish, sorry. So yeah, so Docker expose will publish the port, and host port is what the port the pod will bind on the machine, right? So let me just create the pod quickly. Yeah. The pod is not yet running, it's scheduled. So once the pod is running, we'll see that we are able to go to the machine's port 8080, which we define as host port, and we'll be able to browse whatever it's serving. Now, so this is how a normal application would work. It'll serve something. It'll have an Nginx, it'll have a application running behind it as backend and all those things. The real goal of the talk is to show you how fault tolerant this entire thing is. So what I'm going to do is I'm going to arbitrarily kill one of the containers. Probably will kill the application server or the web frontend, and then we will see how Kubernetes reacts to it. Is it able to recover it? And that's what the target is ultimately. Wow. There are 3 containers running here. This one is Nginx container, which is web frontend. This one is the application, which is written in Flask. And this is the Kubernetes container, which just keeps an eye that rest of the containers which are there in the pod are actually running, right? So let me do this. Let me go to this guy and I will try to open. Okay. Go and let's kill one of the containers. Which one you don't like? Wow, there are so many Python haters here. Okay. So this is I found this as the best way to emulate the crash. So this is going to crash in a minute, and then we'll see what happens. Right. So this has gone down. Let's confirm that it's actually down. Yep. There's no Flask container running right now. So I'm off the keyboard. Let's see how Kubernetes react to it. In the meantime, we'll walk through more such cases where we will do more extreme things. Meanwhile, do you guys have any questions? Like I know this is a bit fast paced because we have 30 minutes and we have to cover a lot.
Why not kill when it's running?
I could have done that, yes, absolutely. It should. As I told you, I will go through very extreme scenarios. This is like a mild one.
Can you show in the browser it is not working?
Yes, I can. If it is not already started. I guess we'll need to wait for a few more seconds before it actually, yep, it's back. Right, so Kubernetes spawned that back up, right? So I got a very good question which said that why didn't you do kill -9? Why stop, which is still graceful, right? I totally agree to that. We should have done something more extreme. How about if I kill the entire virtual machine? Does that sound good to you? So okay, let's do this. I'll boot up two machines. Right, while this is booting, we'll move on to another concept. So pods are highly available within the machines to which they are assigned, but once the pod is dead, it's dead. Okay, once an individual container is dead, pod can bring it up, but what if the pod itself dies? What if your virtual machine dies? Hardware failures are the most difficult scenarios to deal with, right? So that's where we have our next concept, which we call as replication controller. So replication controller is a bunch of pods. So now you can run one pod, you can run multiple pods. You can tell him, okay, so I have got probably 10 virtual machines or probably 10 physical hardware machines, and I need to run these 20 pods, which might consist of 50 containers. So I'll give all these details to Kubernetes, and I will tell them that I don't care how you do it, just make sure that I have 20 instances of this particular application always running, right? So yeah, so in some sense it's kind of the modern definition of full stack developer, you know, the one guy who does everything. So we'll try to do that. I'll just show you a replication controller definition. Is it visible? Right. So here in replication controller, what I'm trying to do is I'm just telling it to run one replica right now. We'll modify it of the same pod which we just ran. The pod definition is there. One thing which I have removed is the host port, because now host port will not make a sense if you are running more than one pods on the same machine, right? I don't want multiple pods listening to the same port. That's not even possible, right? So let's do that. First of all, we'll see Okay, wrong terminal, wait. Not up yet. So, alright, never mind. Till that time, I'm going to delete my pod and run the replication controller. So let's create the replication controller definition which we just saw. Right now, right. So replication controller, it will get booted. Right now, one of the nodes is ready, another one of them is not. So the replication controller will schedule the pod on the one node which is ready. Right. Meanwhile, we'll wait for the another node to get ready. Yeah, both are ready. Okay. So I'm really sorry for this. Give me a minute. Right. Okay, things will be slow from now on because we have more than one virtual machines running on my awesome laptop. Right, so the pod is not totally up yet. Let's see if it's trying to schedule it on this one. Nope. Right, so the controller is up. So it's going to bring back, it's going to bring up the both the containers, and we'll have the node while it takes time. Okay, so while it's taking some time, let me move on to one more thing. Right, so we have one more concept known as services and endpoints. Yep, please.
What is the controller done?
Yeah, that's what we are going to do. If you mean by controller, what do you mean by controller exactly? Yeah, so I'm going to crash the entire machine. So everything will be dead. So don't worry about that. There's one caveat is what if your Kubernetes API server dies? Yeah, that is the one which we need to worry about, because somebody needs to tell the nodes what to do, and there has to be that one machine which should be up. Although the entire data is stored in etcd, which is inherently highly available, so you can bring back any node and the data will be retained. You're not going to lose anything as long as your etcd is well configured. So that should work out of the box, right? But so services and endpoints is one concept where so there are scenarios where you are not sure if there are multiple pods running on whatever machines are running, how to expose one end of the pod to another pod. So all those networking issues where you need two pods to communicate to each other, you can manage all those by using services and endpoints. We are going to create an endpoint in some time once we get the replication controller up, and then we are going to see how seamlessly it handles. Yes? Anything? Any questions? Yeah, that's fine. Don't worry about that. It's because I'm running a lot of stuff on this machine and sometimes it doesn't like it. Yeah, so replication controller has booted up Nginx as well as Flask. Now we should bring the service up. Because if you see, we didn't define a host port. So technically right now we have no way to access the application, right? We don't know, ideally we have no idea where the replication controller will start and on which machine it's going to schedule the pods, right? We don't know that. So services help in this scenario. here is the service declaration. So what service will do is that it's going to target the Nginx Flask pod, and it's going to bind the port 8080 to the node port 30061, which it's an arbitrary port. By default, you're only allowed to use ports above 30,000, but you can configure that. Right, so we have created the service as well. So right now what I'm going to do is I'm going to go here. If I try to open this, it will not work because it's not listening there anymore. This should work. Yeah, I'll crash. Wait, give me some time. I will crash this node. So we'll access it on some other node thing. Yes, you are right. But I'm not sure if I've configured it for that. I didn't check it. Okay, that one is surely down. What the hell? Firefox is trying to be smart actually. Let's just see what state they are at. Yeah, looks up to me. Come on. Okay, I'll give it a minute, otherwise we'll just go ahead with the crashing. Anyway, in the meantime, do you guys have any questions or anything? Yep. Yeah, because now we are not binding it. So I commented out the line which had the host port bound. So that port is no longer being listened to.
Showed the second file with port 8080, right? So that's fine.
Yeah, so what happens is that pod will still bound to 8080, but it will not be exposed to the. So pod will expose the port, but it will not be bound to the host. So this service is going to map that 8080 to 30061. Ideally, I could have done that. I would have done 80802 instead of 30061. It's just that then I would have to change the config file to listen to that. By default, Kubernetes recommend that you use 30,000 and above. That's all.
Right now you have two VMs, right?
Right now I have two.
VMs, right?
I have two VMs. Yes,
In which you are running pods.
I'm running pods.
Previously you said I cannot allocate the same port to two VMs. You can
Allocate copies. You can have one copy here, one copy here.
right,
Right.
but you cannot have the same host port.
Because, okay, so if I have one virtual machine, right, I cannot have two of the pods running here who tries to bind to the same host port. Only one service can bind to the same host port, right? That's why we removed the host port from the configuration. When we try to run multiple of them, it's advisable to remove the host port, because binding will not happen. Your pods will keep on crashing. They won't be able to bind and they'll crash.
What is this 30,061 port?
It's a random port. I could have picked 62 or 68 would have worked. Just a random number. much time. Okay, I have just about 6 minutes. I'm going to crash this, guys, in hope that it will work. Okay, I will get back to you with this, but let me just crash this one. So right now what I see is that we have the containers running on this one, which is essentially this machine, and I'm going to force off it. Okay. Yep, the machine is dead. I cannot do anything there. Let's ask Kubernetes. Yeah, it'll take, I think, a few seconds. All right. Yep.
What are the ways we can interact with Kubernetes?
What are the ways? So Kubernetes has command line tools, which is, so you run kubectl on the Kubernetes server, and you run, so kubeproxy and kubelet. Kubelet is the major workhorse which does the entire work that runs on the individual nodes, and they all interact via etcd server. Not a pretty one. We have web API. We have APIs, but there's no pretty dashboard that I know of, at least. Yeah. So we see that at least this one has crashed, right? Let's see if Docker has, if Kubernetes is, no, not yet. Yep. So entire thing is a bit slow. I have multiple virtual machines running. Yep. Yeah. It will take care of. No, etcd is not for the recovering of the data that are on the nodes. What happens is that whatever pod definitions I'm doing, whatever replication controls I'm creating, that data of what I am doing is sent to etcd, and the kubectl sends this data, and the kubelet, which is the working agent or which is installed on the nodes, it fetches the data from using API servers and all those things. If I get your question right, you want to ask what about the high availability of etcd itself, right? Yeah, so etcd is a distributed store anyways. The ideal way of running etcd is to make sure that it's running on multiple machines, and that is one part I think which you have to like think about how to set up your etcd. But once etcd distributed storage is done, etcd is pretty flexible in itself and quite highly available. Okay, yep. It just stores the data, right? The management is taken care of by kubectl. kubectl schedules the tasks. Let's say that there are 10 nodes and one of them went down. Okay. There will be heartbeat sort of functionality, and kubectl will eventually find out via API servers and etcd that one of the nodes is down. So it's going to schedule the same pod, the same replication controller or pod to another machine. Once that is back up, it will not be moved. It will be there until something else crashes and there is more workload to this guy and it needs to reschedule something.
Okay, so this means the centralized storage
that's what I'm saying, that centralized storage is etcd, and it is chosen because etcd itself is very distributable. You can make etcd highly available very easily. It's designed in that way.
Yeah, that I am talking about. If centralized storage goes down, you can't recover that.
Yes, if all of your nodes of centralized store are down, then you cannot recover.
All of your nodes in centralized storage?
Yes, all of your nodes of centralized storage went down, then you cannot recover. Yes. Time is also up. So, okay. I'll try to do the last curl and then we'll wrap up. If you guys have any more questions, you can catch me. Okay, only Nginx is up. The application is not up yet. Alright, if you want to see the demo, I'll just walk down somewhere there and we can continue. If you have questions, you can catch me there. That's all I have right now. Yeah, I'm sorry, the demo didn't work end to end, but I actually needed more time. Thank you.